so let's look at this practice problem to see how we can use our two-dimensional rate units as a conversion factor as well. So the rate units, like I said, are going to be some measurements in the numerator over time. And this is really helpful when we're looking at some of the word problems that we're dealing with in both physics and in chemistry. So here we have the speed of light is 3.0 times 10 to the 10 centimeters per second. So this is a rate-derived unit, two-dimensional unit. So we have some type of length or some type of unit in the numerator. And in this case, it is a distance or length per time. So that's what the second is. So we have sunlight takes 8.29 minutes to travel from the photosphere, light-producing region of the sun, to Earth. How many kilometers is Earth from the sun? So if we had to start dealing with the speed of light equation, manipulating that, then doing all of the conversions, plugging in there, it's just a lot when we can do it in a simple dimensional analysis form. So just like we did in any of them, the first thing I'm going to do is I'm going to take my two-dimensional unit and I'm going to make it into an inequality that I can use. So what this is saying is that for every 3.0 times 10 to the 10 centimeters equals 1 second. Okay, now we obviously are going to have to use some other conversion factors, and that's just our metric to kind of go in between the different metric units. Here we're going to have our one-dimensional unit. So our one-dimensional unit right here, notice the only unit it has is time. We don't have it in a fraction form. It's just time. That's where we're always going to start. So I'm going to take that one-dimensional unit. Okay, and we are going to get it in a form where we can use our rate conversion factor right there, right? So that is in seconds and our given is in minutes. So we need to convert minutes to seconds to be able to use our rate conversion factor because we have to have our units match up. So I'm going to do that by converting minutes into seconds. And so that right there is for every, let's see here. So for every 1 minute, we know there are 60 seconds. So we're going to use that conversion factor in our fractional form. Minutes is going to have to go in the denominator so we can get minutes to cancel out. So 1 minute, and then we got the 60 seconds. All right, so now minutes are going to cancel. So now we are in seconds. So now because we're in seconds, we can go ahead and we can use our conversion factor up there because you can see for every 1 second, this is how many centimeters we're going to move. So I'm going to place that in my fractional form. So because seconds is the numerator in the previous step, it's going to become our denominator in the new step. So 1 second, and then I'm going to use the 3.0 times 10 to the 10 centimeters. So now we're out of seconds, right? And we're left in centimeters. Now, the final unit that it wants us to be, so if I were to leave it here, it's in centimeters, but it does not match what unit it was asking for. So now all we got to use is our metric conversions to get into millimeters. So the first thing we do is we're going to go into the base, and the base is the meter. So I know from my chart, and I use your chart if you need it. It is located and the button next to this lesson, so you can have that and print it off. Here we have for every 1 centimeter, it is equal to 10 to the negative 2 meters, right? So that's using our chart. We know that we always put the 1 with the prefix and the multiplier goes with the base unit. So I'm going to set this up in my fractional form. We got to cancel out the centimeters. So centimeters go on the bottom so it can cancel and we can be left in the meter. Again, if we stopped right here, we are in meters and the question asks for kilometers. So we've got to go one more step. We're going to go use the kilometer prefix. So it says for every 1 kilometer, we have 10 to the 3 meters, right? So again, the 1 goes with the prefix, the multiplier in that table goes with the base unit. So now we can set this up to do one more cancellation. Meters is on the top. We need it to be on the bottom, so I'm going to put that information from our equality there, and I'm going to have kilometers on the top. So meters cancel. I am left in the kilometer. So we know, because of the way I set it up, the way the units all canceled, we know we are left in the correct unit. So that means my numbers and my math, all I've got to do is plug it in now. We did it correctly. So if we simplify this and we just put our values, so I got 8.29 times 60 times 3.0 times 10 to the 10 times 10 to the negative 2, all over 1 times 1 times 1 times 10 to the 3. So we're going to go ahead and simplify this by plugging it in the calculator. So 8.29 times 60 times 3.0 to the 10. Remember, when you're plugging in the calculator for that scientific notation, make sure to use the second comma to use that E so we don't mess up orders of operation. Remember me telling you guys orders of operation can get funky if you start not putting it in the calculator correctly, and we don't want to do that. So our top number here is going to be 1.492 times 10 to the 11. All over 10 to the 3. So we're going to go ahead and finish this out. Again, I'm using the second comma to get you that E, so we can write 1.492 E11 in the calculator, so we don't screw up the order of operations there. All right, and we get a final value of 1.492 times 10 to the 8. Now, I cannot leave it like that, because if you look at the sig figs here, we have 3 there that's given to us, and then we only have 2 there. So we always go with the least number of sig figs given, so we can only report 2 numbers. So our 2 numbers are going to be the 1 and the 4. And we're going to look next to its neighbor here to determine if the 4 stays a 4, if we round it up. And because it's a 9, we actually are going to be left with 1.5 times 10 to the 8 kilometers as our final answer. So there it is. Now, this goes much faster. So this was a really big problem. So this was a very challenging problem and would be like an extra credit type problem. But you still should be able to do it, because all it is we did a unit conversion, unit conversion, unit conversion, and then this conversion came from our derived rate unit. Okay, so it's something you could totally do. You just set it up so that you're canceling out the units.